Well, just to review our setup, we have a brushless motor wired up to the motor controller and also connected to some gears and a belt just for the demonstration. And in addition, we have a Raspberry Pi Pico, and that's wired over serial UART connection to our O-Drive motor controller. So this Pico is doing a couple of things. First of all, it's sampling data, more specifically power consumption data from the motor controller. And it's filling up a buffer with this data and then passing the buffer through the anomaly detection model that we trained. And I'll just open up here the O-Drive reference. And in this case, the property that we're accessing is electrical power, but you can see there's no shortage here of different properties that we could potentially make use of. And this is just this is true for the O-Drive controller, but it's also true for many sort of industrial grade motor controllers. For instance, Robotech controllers would also be relevant here. It's not uncommon for them to have some sort of interface and expose these sort of properties over that interface. And that's really interesting for us because that means we don't actually have to add any additional sensors. We can just use the existing hardware and interface using our own code and our own model to produce some pretty useful results. Now, in addition to the motor, we also have a little fault panel here with a LED, and this LED will light up when our model detects an anomaly over a certain threshold. So I'm just going to go ahead and start the motor running and be right back. Okay, I've got the motor running, and I'm not sure how clear it is over video, but you can probably hear in the audio that the velocity of the motor is just changing pretty sporadically and randomly, and that's being done over a Python script that I wrote that changes the velocity in a random way. And this is meant to simulate maybe a robotic arms joint or some sort of robotic motor. I didn't want to use something with a constant velocity because I thought that might be too easy. So this motor is producing, let's call it a messy power signal at the moment. And we're going to see if, despite the messiness of that signal, whether we're able to pick up on anomalies. So I'll also open the Arduino serial terminal here. And you can see that every second we're getting these readings, and each one has an anomaly with a number. And the reason most of them here are negative is because that number basically represents where that 1 second sample falls in reference to, where it falls in reference to the clusters that were created when we trained our model. And negative number basically means that the sample falls within one of the cluster circles, and the number actually is just the distance from the closest edge. And actually here you see that we had a positive one. That means that we had a sample that is considered an anomaly by the model, but I set here a threshold of 1.2, and that threshold can be adjusted depending on what sort of setup you have. So we're going to see what sort of anomaly ratings we get when I introduce some sort of mechanical disturbance to the motor's motion. So the first thing we can try is to sort of block the belt here. So I'm going to try that. And we see that the LED did light up, and we got an anomaly rating of 4.454, and that's interesting. Let's try also to block here the shaft. Okay, that probably give us that gave us a real big anomaly rating of 137.526. And yeah, there's all sorts of different ways we can mess with the motor here to get these anomaly ratings. So just to review, basically what we've done is we've trained a model using this kind of motion, and the model created clusters of expected behavior, or let's say average typical behavior of the motor, and it's constantly reading the current behavior of the motor and telling us when the motor's behaving in a way that is atypical. And so this is really useful and, like I said before, minimally intrusive. Very, very useful if you don't want to simulate faulty behavior, and that can be very dangerous and damaging. And that's all for now. And I recommend, if you have any questions, to go to the Edge Impulse forum. It's full of very talented, helpful people. And feel free to also post comments here, and I'll try to get back to you. So that's all for now. Thank you.